And I'm at 13.99 rating. So I think I broke it. I broke 1400. I'm at 1401. Oh, and this one is paywalled. Okay, so we're gonna try and do 5 again today. Try and do 5. Minimum rectangles to cover points. You're given a 2D integer array points where points I is equal to xi, yi. You're also given an integer w. Your task is to cover all given points within or with rectangles. So cover all the points with rectangles. Each rectangle has its lower end at some point x1. Each rectangle has its lower point at some point x1, 0, and its upper end at some point x2, y2, where x1 is less than or equal to x2 and y2 is greater than or equal to 0, and the condition x2 minus x1 is less than or equal to w. Must be satisfied for each rectangle. A point is considered covered by a rectangle if it lies within or on the boundary of the rectangle. Return an integer denoting the minimum number of rectangles needed so that each point is covered by at least one rectangle. So W is the width. But the points have to be within the width, pretty much. Okay. So what's the minimum number of rectangles needed so that each point is covered by at least one rectangle? So in this one, we have width 1. And we have all these points. And so aligning it on 1 to 2 and 3 to 4 is going to be the minimum. So how are we going to figure out where to align it? This was interesting. Can they not overlap? Like, can this rectangle be here and then we have another rectangle here? Why did it need to? I guess it doesn't matter. I guess it could have done that. But in this example too, the width is 2. We have, there could be 10 to the 9, or x can be 10 to the 9, y can be 10 to the 9, w can be 10 to the 9. And the point's length is 10 to the 5. All pairs are distinct. Okay. So the grid is going to cover the grid should cover the maximum x and the maximum y of these points. Maybe we have to find the distance between 2 points. Hello, Glump. Thank you for the follow. Welcome. What the freaking heck? What's up? Are you surprised someone's streaming from the Discord? All right, so let me think. So each rectangle can go up as much y without creating another rectangle. Like, I don't need to worry about the y. So I really just need to worry about the x when it comes to how many rectangles I'm using. So maybe I'm looping through the points and what's up, Dev? Thank you for the follow. So I'm looping through the points and then I gotta use W to check if I can cover those points. A. Like for these points here in the example, we have x, bunch of x points on 1, or a bunch of points on x equals 1, a bunch of points on x equals 2, 3, 1 point on x equals 2, 1 point on x equals 3, 1 point on x equals 4. But how do I know how to create the rectangle? Maybe as soon as maybe I can Maybe I sort the points. And maybe I sort. What if the points were at 0 and 2? Then I would put a rectangle on the 0x, or on the x equals 0 spot. And then I would start up again on 2. How do I know not to put it on that spot? So I don't put it on a spot. Maybe I can go, like, I know the minimum and the maximum x, right? And then maybe I just check each. So the minimum and the maximum x is 10 to the 9, so that's gonna be too much to go like for through every point in the axis. So never mind. But yeah, maybe I need them in order. For example, this is one that's in order. And I can check the x of first one to the x of the second one. I like how the daily was a matrix problem, but instead of giving you a matrix as the problem, data, Leetcode said, here's the row and column sums, you figure out what the matrix is. That's pretty interesting. It's different. Did you get it? Did you solve the question? Yeah, so maybe I start with the first x in a sorted array, and I add w to that value. And then I skip points until I get to a value outside that range. And then I just set w plus that point. And then I skip points again. That's probably that's what I could do. It works. So again, I sort the points by x value. Start with a point and add w to x value. Skip points until next x value is greater than the previous sum. or w plus x. Better way to say it. Because I don't need to worry about y. And so I think sorting is fine. And if I sort, then I just need to... I think this works. Let's try it. So... points is equal... Or do we do points dot sort lambda is it like this? Lambda x lambda x for x. A0. This might be wrong. Or it's lambda key is equal to lambda x is 0. Maybe that's it. So in this first one, I sorted by 1. Yeah, okay, so there we go. So I have it sorted. Then for x, I don't need the second one in points. But I need to compare it, right? No. I don't need to compare it. I just need to have a previous though. So maybe do res is equal to prev is equal to 0. And then we say for x in points, prev is equal, or let's just do, yeah, prev equal to x plus w. So we can do less than or equal to. Or we do we continue if it's no. So we add one. Only add one if it's greater than. Right? So if x greater than priv, res plus or equal to 1. Okay, so here we start at 1. We add w, which is 1. So now we have 2. We go to the next one. 1 is not greater than we only want to set this when after this change, right? Yeah. But that means that we need res equal to 0 and prev equal to x plus w. And so once we get, so we skip this, skip this, skip this. Once we get to 2, it's still in there, skip that. Res also has to be start at 1. You gotta have at least 1. And then once you get to here, now we start another one. We get in here. 3 is greater than prev. Add 1 to the count. And then we start again at 3 plus 1, which is 4. The next one is in it. And then we just end. So I think this is it. So I need points. Zero, 0 plus w. It's the first index point and x plus w. Okay. All the test cases are good. Let's see. W is equal to 100. 100, 99, 56, 54, 35, 53, 46. Let's try that. Run. I'll put one expected one. Let's make it a low number. Make it 7. That's 4. I think I got it. Let's go. So I'm sure there's probably a way to do without sorting, but sorting worked because there's only 10 to the 4 or 10 to the 5 in the list. And sorting is n log n. And then I'm just looping through. right. That's a good one. Next one. Range sum of sorted. Let's do time. Range sum of sorted subarray sums. You were given the array nums consisting of n positive integers. You computed the sum of all non-empty continuous subarrays from the array and then sorted them in non-decreasing order, creating a new array of n times n plus 1 divided by two numbers. Return the sum of the numbers index left to index right, index from 1, inclusive in the array. Since the answer can be a huge number, return it modulo 10 times 9 to the 7. Okay. Given the array nums and positive integers, you computed the sum of all non-empty continuous subarrays from the array and then sorted them in non-decreasing order, creating a new array of n times n plus 1 divided by two numbers. Return the sum of the numbers from the left to index, from index left to index right. Okay, so what's the constraints? There's only 1,000 numbers. But the thing is, one to five. Interesting. I don't get what right 5 means. There's only 4 in the index, right? 1, 2, 3, 4. Hey Fumi, what's up? I'm just waiting for Lumiterra to start again. I didn't make my money, so they better give me the Ronin pass. Charity auction, nice. Yeah, that's true. That is true. Wow. Oh yeah, I saw that. I saw someone bid on Twitter. Someone bid that high for Pokemon, playing with Pokemon. It's crazy. It could be a someone down bad also. That specific one. What do you mean by pretentious? You can see the people. Is someone streaming it right now? Were you watching a streamer? What streamer were you watching? The host. Oh, okay. I don't get this problem. There's a number to the right, and I don't get what the purpose of the number is. I don't get what the purpose of it is. I think I get the gist of what I'm doing. I'm adding the numbers in the subarrays. The sum of the numbers from index left equal 3 to right equals 4 is 3 plus 3. Oh, okay. So all the subarrays are going to be in... So I actually have to, like, create this index or create this list of numbers, then I have to sort it, then I have to sum from the indexes. One, two, three, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 numbers. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So right's gonna always be less than or equal to n times n divided by 2. N times n plus 1 divided by 2. Yeah, okay. Where is the question? Oh, the question's up here. You're given the array nums consisting of n positive integers, you computed the sum of all non-empty continuous subarrays from the array and then sorted them in non-decreasing order, creating a new array of n times n plus 1 divided by 2 numbers. Return the sum of the numbers from index left to index right. Since the answer can be huge, return it 10 to the 9 modulo. So do res is equal to 0. And I have to return res modulo 10 to the 9 plus 7. So yeah, I have to loop through and create these sums. But I feel like I don't need to loop through to create the sums, do I? Sometimes I read English and it doesn't make any sense. Well, this is definitely more difficult. Difficult phrasing, difficult problems to solve, so it makes sense that you wouldn't understand. I'm just getting used to it now to be able to understand them. I used to sit here and be like, "Durr," and just not be able to solve. Okay, so the question is, do I just loop through and loop through and calculate every number looping through, or do I try and figure out how to do that without looping twice? I probably should just do it. If I'm at this index, it's just a number. If I'm at this index, or this one would be okay. Like I can use this formula maybe in some way. Nah. Okay, so let's do the loop. Let's do the loop. So we have for I in range length nums, for j in range 1 length of nums. And so each number of I we can add to the subarray, right? So the first thing we're gonna do is we're gonna do subarray. We're gonna append. All right, let's do. Let's make this res. Res.append. Doms. I. So we're going to add each number as we go through. But then for j, we're going to keep a running sum. So let's keep run. Or let's do x is equal to 0. And we keep this running till the end. We just keep adding that to the array. So x plus or equal to nums j. We gotta start with nums I, right? Start with nums I. X plus or equal to nums j. As we loop through. And we append res.append nums j. Or sorry, x. So yeah, we're gonna append 1. Put 1 in here. And then we have 2 in here. So 2 plus 1 is 3. Append 3. And then we have 3 plus 3 is 6. Appended here. Okay, so wait a second. Yeah. So I'll just keep doing that. It's fun. 1, 3, 6, and then we have 10. And then we end, and then we go to the next one. 2. Yeah, so that should be good. And that should give me the subarray. So we can check it out. We can print res, and we can also for now just do the length of I gotta sort it. Let's sort it. So res.sort. One, 2, 3, 3, 4, 4, 5, 6, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so something went wrong. I don't get it. It should be 1. All right, let me see what happens without the shorting. Without the sorting. So 1, 3, 6, 10, like normal. 2, 4. 2, 4. It should be. Oh, okay, I see. I'm doing 1 instead of I plus 1. There we go. All right, so we got it right. Now we want to sort it. Res.sort. And then we want to add. So we just do the sum of res left -1 and right can stay the same. Right. So left and right. It should just be the sum, right? Okay. I think we're good. All right, let's try it. Let's add a test case. I don't even know if that's possible. I don't know if this is possible. 9. Let's do that. And let's do 9. All right. I think that's good. Submit. Let's go. Only 22 minutes. All right. Completed 2 problems. Let me get some water. 2 problems so far. 2 1,400 problems. Doing good. Get some water. All right, number of students unable to eat lunch. The school cafeteria offers circular and square sandwiches at lunch break, referred to by numbers 0 and 1 respectively. All students stand in a queue. Each student either prefers square or circular sandwiches. The number of sandwiches in the cafeteria is equal to the number of students. These sandwiches are placed in a stack at each step. If the student at the front of the queue prefers a sandwich on top of the stack, they take it and leave the queue. Otherwise, they will leave it and go to the queue's end. This continues until none of the queue students want to take the top sandwich and are thus unable to eat. You are given 2 integer arrays, students and sandwiches, where sandwiches I is the type of ith sandwich in the stack. I is equal to 0 is the top of the stack, and students j is the preference of the j student in the initial queue. J is equal to 0 is the front of the queue. So j is equal to 0 is the front of the queue. Return the number of students that are unable to eat. So this is the top of the stack. And this is the Do I just reverse both of them and check? Reverse both of them, loop through. Oh, no. Or not even reverse both of them. Do I need to even do that? Start the index at 0. And then if the student at the front of the queue prefers the sandwich on top, they will take it and leave the queue. Otherwise, they will leave it and go to the queue's end. So I gotta like actually loop them around. Okay, so I gotta create a queue out of students. Sandwiches. I can just move the index. But it ends when none of the queue continues until none of the queue students want to take the top sandwich. How would I know that? So if I keep looping them around. Like, let's say I loop them around, and then someone takes a sandwich. Turn the number of students that are unable to. Leave it and go to the queue's end. I'm just stuck on, like, if I were to do what it says exactly, and let me just write it down so that way. So let's turn the students into a queue. So queue or students is equal to deck students. So now I can pop left and append. Maybe I just, if I pop okay, so output is equal to number of students that are unable to eat. So I think I loop through sandwiches because I don't loop through students because I can't. I'm stuck at the top of the sandwich. Right. So I just start I is equal to 0. And we say while I is less than the length of sandwiches. Hmm. Maybe we do while students. Nah. Let's see. Because I need to end. So they leave the queue if they take it. So while students or while students and visited is less than the length of students. And then the reason I do that is because I think that I need to figure out when each student has tried the top sandwich, and if that reaches that point, which is the length of the students, then we exit and but then we need to return the students that are not unable to eat. Right. Which would be, yeah, the size of the students. But Am I popping out of students? Because if I'm popping out of students, yeah, it's fine. It's gonna change and that's fine. So I think that's good for now. And then so now while students and visited is less than or equal to length of students. So let's do if students dot pop left all right, let's do students dot pop left is equal to s. And then if s is equal to sandwich is I. Then we're gonna do I plus or equal to 1 to move the sandwich, and we just leave it out. So we're just moving the sandwich over, right? Now, otherwise, they will leave it and go to the queue's end. So otherwise, you leave the sandwich, you don't increase the index. You gotta go to the queue's end. So students dot append s, but also now they visited it, so visited plus or equal to 1. Thing is, also once they now eat a sandwich, we reset visited to 0. And then at the end of it all, we return the length of students. It could be 0, it could be, if it's stalemated, meaning like we get to the end and the visited is now the size of students, then we just count how many students are left. Let's try that. Right, I think that's it. Let's go. Okay. It's easy once you have the queue. Find the positive integer solution for a given equation. Given a callable function fx xy with the hidden formula and the value z, reverse engineer the formula, and return all positive integer pairs x and y, where fxy is equal to z. You may return the pairs in any order. While the exact formula is hidden, the function is monotonically increasing. We'll judge your solution as follows. Your judge has a list of 9 hidden implementations. If the results are P solution. You should not implement it or speculate about its implementation. I've never done a problem like this before, I don't know. So what am I doing? Function ID 1 z is equal to 5, output. Given a callable function with a hidden formula and a value z, reverse engineer the formula and return all positive integers x and y, where fxy is equal to z. All positive integers x and y, where fxy is equal to z. Integer pairs x, y, where it's equal to z. Function ID 1, z is equal to 5. Function ID 2, z is equal to 5. Engineer where all pairs are equal to z. So I just gotta put the pairs through a function and return where they're equal to z. Okay. It is guaranteed that the solutions of fxy is equal to z will be in the range 1 to 1000. It is also guaranteed that fxy will fit in a 32-bit signed integer. Do I just perform the function on all pairs? from 1 to 1000. What do I do with custom function? Custom function returns fxy for any given positive integers, actually. Note that fxy is increasing with respect to both x and y. fxy is less than fx plus 1. Oh, okay, I see. I guess that means maybe I don't know what that means. Okay, so maybe I just find all the pairs and I see which ones are equal to z. So for I in range 1 to 1000 plus 1. For x in range, for y in range. Res is equal to a list, and then if this is equal to z, then we append x comma y. So we loop through all the possible pairs. And we just see if they're equal to Z. That'd be self. No. Object has no attribute custom function. No, it's a parameter, right? Custom function, but how do I use it? How do I use this thing? I don't get this question at all. Probably doing it way wrong. Anyone know how to use this function? ChatGPT. How can I use this? That barely passed. So it passed because 1,000 times 1,000 is like you know, million. So million's slow though. It's 10 to the 6. So how could I do it faster? How could I do this faster? Well, I know if let's think so this is 2 to the 5, maybe 5 1. What if I did x plus 1? What if I did that? 1 5, right? And then what if for each one I just flipped it? How do I do that? I did this. res.append fxy and yx. Let's run that. No. This output should be nothing, and I have 1 1. Or this output is nothing. And it should be 1 1. So I need to add 1, 1, 2, 2. Maybe I could do that on the others at the top. I could do this. If x is equal to z, So in this one, I'm adding. So basically what I want to do is check if this, I just want to check every case then. I feel like I'm repeating a lot right now. It's still a lot. I cut it in half, but what else repeats? So if I'm just adding 1, can I just do this? Plus 1. No, because I'm like, no. I need to keep going, right? Keep going, keep going. I don't know. I solved it, I guess, and I'll just get help later. I think I'm gonna go to sleep though. I did 4 questions. 4 solved. 4 solved. Now I'm up to this one. I think that's pretty good. For the week, I have 17 problems solved. 17 problems solved in the week, and I'm at 1400 ranking now. Alright. I'm going to end and go to sleep. Although it's only 10:30. You're given a binary array nums. We call a subarray alternating if no 2 adjacent elements in the subarray have the same value. Return the number of alternating subarrays in nums. And 10 to the 5 is the length. 10 to the 5 is the length of nums. I can't find all subarrays, right? Because that would be quadratic. Oh, that would be quadratic. Alright, I'm gonna try this tomorrow. I'm out of here. Goodbye. Thank you.